Good morning. Let us start. So those of you who are in the room, you notice that there are more people in the room than we usually have. Yeah, we are happy today to welcome some guests from Latvia, Portugal, Hungary, and Germany. Yeah, and they are interested in how we do this teaching work here. So we are very happy to have you. Yeah, and you are welcome to look at what we are doing, but you're also welcome to ask questions and really participate if you find it interesting. This course that you are happen to be in is called Metrology in Chemistry, and this is like let's call it Fundamentals of Analytical Chemistry, a course which attempts to teach the students how to get chemical analysis results right. So this is what it is about. And right now we are in the middle of something called certified reference materials. And these are reference samples that you can buy from somewhere, and you buy them with a certificate which tells you how much of some toxicant or trace element, etc., is inside there. These certified reference materials are a very important part of quality assurance and getting results right in chemical analysis. So, but now, this was the last slide we looked at yesterday. And before we move on, any questions about this or about any previous slides? People on the internet? No. Also no. Okay, if not, then yesterday we managed to finish the production of certified reference materials. So now we move on with selection. What I mean by selection here is, how do you select which CRM to buy? And how do you make it sure that it really is suitable for your purpose? So essentially, if it is a matrix CRM and you want to use it for any of the, let's say, quality assurance activities that we will look at somewhat later, then it has to match your sample well. So the certified reference material indeed should have a composition which is as similar as possible to your regular routine samples. And you see now that there are a number of things that should match. Yeah, first of all, it should or has to be the same analyte, the same or similar matrix, similar analyte level. But oftentimes people ask, how similar is similar? Yeah? And there's no clear answer to that. But I would say that a practical approach is that as long as the difference is not more than 3 times, you can still consider it similar. Sometimes I say 3, sometimes I say 5, yeah, but at least less than 10. And if it's below 2 times, then it's just perfect. Yeah, then it's really, really very good. Then if sample preparation method is specified, it should be the same. This, of course, applies especially with those method-dependent certified reference materials. Remember, which we looked at, which are about leachable lead or bioavailable phosphorus, etc., etc. And of course, suitable measurement uncertainty, which we also discussed yesterday. But now, question to you. I've listed here 5 different things. Some of these are absolutely mandatory. Some of them are not so mandatory. Yeah? So, would you tell me now, let's see, which of these are the most important and why?
I would say like the most important one, same analyte.
Yeah, correct. So here there's no dispute. Yeah, if your analyte is something X that CRM has to be about X. Yeah. So let's paint this one red. Yeah, this is absolutely mandatory. Okay. Anything else?
One could be the similar matrix.
Similar matrix, perhaps here we take like orange. Yeah, this is also very important, but still it's somewhat different. We can still live with. Yeah, I'll explain later on why I'm saying that. Let's paint this one orange. Anything else? It's like, let's say, absolutely necessary or more or less necessary.
Very important.
Yeah, I would say analyte level, I perhaps would even paint yellow. So yes, it is important, but here it's sort of more flexible. As I said, 3 times, but okay, if it's 4 times different, still useful. Yeah. So let's paint this one yellow. It's maybe not slightly less important. No? Okay. But is there anything red? Yeah, here also you can make some compromises. The uncertainty part, I would perhaps paint orange again, so that it's, it is important, yes, sure, but maybe not as important as one more thing that is. Well, yeah, we have now only one thing left, yeah. So let me jump back for a moment, yeah. So if it is method-dependent reference value, then using the same method is absolutely mandatory. So that, for example, if this is extraction according to the ISO 11466, then you absolutely have to use that. This is more or less as important as having the same analyte. Yeah. So that one we also should paint red. Okay. Good. Here we managed. Yeah. So we now have the 2 reds, 2 oranges, and 1 yellow. The yellow is not so well visible. I think you probably understand. But now there's another question where again I would like your help. How do we know which is suitable uncertainty? What considerations might there be? Yeah, take the microphone.
I would maybe ask a question of my own. How different may different certified reference materials in terms of uncertainty be, and how that affects the price? Because it seems for me that that's the most important thing considering materials.
You mean the price is the most important thing? No?
I mean, as the price and uncertainty might be somehow correlated, because it seems like the more effort you put into making certified reference material, the better uncertainty, or the better the uncertainty reflects what the actual uncertainty might be with that matrix and analyte and all that stuff.
Yeah, you have a point. Actually, I haven't really tried, and it's a very interesting proposal, actually. I haven't really tried to correlate price with uncertainty. But I think if you involve into that correlation different analytes, different matrices, you will not get the good correlation. Because even in spite of maybe very high uncertainty, some trace analytes in some nasty matrix might be very difficult to determine, so the price might be high. And yet uncertainty also might be high. So probably there's no, but again, I haven't really tried. there's probably not such a big correlation. And let me say one more thing. The prices, again, it's a very good point. Matrix certified reference materials are not cheap. But by saying are not cheap, I mean not cheap in everyday layperson terms. Yeah, one package or one bottle can cost something like 50, 100, 200, etc. euros, maybe even 300. Yeah, which is a lot of money. Yeah, let's say for you and me. But for an analytical lab, which has large turnover, yeah, many samples, etc. And obviously, the CRM is not used every day. Yeah, it's used for during method development, validation, then maybe occasional checking later on. It's not such a big expense, actually. So I would not say that the cost of certified reference materials is the biggest issue. Yeah, you wanted to ask something more? No? Ah, I managed to answer. Yeah. Okay. Now let's see. 2 people have, or 3 people actually have said something on the internet. Yeah. Hans is saying the purpose of the analysis. Some regulations have specified uncertainty. Correct. Yeah, can be. Yeah, let's come to that in a moment. Yeah. Louis said the suitable uncertainty should be less than the legal metrology threshold for the analyte. Yes, okay, yeah. If that legal threshold really exists, then this makes sense. Yeah. Elvin says, I would say the uncertainty of the CRM should be smaller than the uncertainty we hope to achieve with our method. All right. So we now have 4 interesting proposals. Anything from the room? Yeah, Maitane?
Can be summarized like what you have said in the beginning of the course, like fit for the purpose, like able to make decisions.
Correct. Yeah, perfectly correct. But now let's make one step further. What could be the criterion of being fit for purpose in this specific situation?
Like it was when you were able to make decisions from like your results and your uncertainty, like all in the legal field or in the search fields.
I think you answered actually very well. At this point, we are not going yet into any like formulas or calculations, but this fitness for purpose and being able to make decisions is the key thing. And now in this specific case, if we now want to have as like exact answer or as detailed answer as possible, then I think Elvin has said it essentially. It should be lower and preferably significantly lower than your target uncertainty. Otherwise, you cannot really check your method. Let's say few times lower than the uncertainty that you plan to achieve with your. Then you really can check your method against the CRM and find out whether there's agreement or not. Because if the CRM's uncertainty is very wide, there's almost always like agreement. Yeah, even if you are completely off, you still sort of agree. We will later on look at concrete formulas and mathematics. How do you determine agreement between your value and CRM? But in any case, uncertainty should be low. Clear?
So this Elvin proposal seems so obvious that it doesn't seem any sense to make CRMs which do not provide uncertainty lower than you would be able to achieve with your method. How is this viable?
You see, different methods at different labs have different uncertainties. For example, I happen to know for sure that at least in one prominent pesticide analysis lab, their typical uncertainty, and now I've forgotten whether it's expanded or standard uncertainty. I think it's expanded uncertainty. Their typical expanded uncertainty for all pesticides is 50% relative. So if their own uncertainty is 50%, and that's not bad analysis, let me stress. If the uncertainty is 50% relative, then if the CRM uncertainty is 20% relative, pretty okay actually. Yeah? So you see, sometimes the uncertainties of labs might be higher, sometimes lower. Some other lab might do some really high-level analysis of that of the same test design, yeah? and want to achieve like expanded uncertainty plus minus 10% relative, which I think is doubtful whether they can if it's a complex matrix. But then plus minus 20% relative does not enable them to challenge their method. Yeah? Now, please.
I would then ask on what are there different grades of CRMs that you are able to use considering the same analyte and the same matrix? So some of them have a bigger uncertainty range, some of them have lower. And what's the differences? Are they in orders of magnitude? Are there times differences?
You are giving me a very good idea. I took the wrong one. Let's just look at this one. I already showed it yesterday, but let me just show it again. So this is one certificate of a CRM. Yeah? We will come back to that later on to analyze whether everything is written down there as it should. If you now look at the expanded uncertainty, this expanded uncertainty at 95% coverage probability seems to be, if I'm not mistaken, something like 7% relative, I think, more or less. Yeah. So expanded uncertainty, 7% relative. For trace analysis in complex matrices, this is very good. Now, I make a note for myself because in the future it would really be useful for me to put here a slide with some examples. But I can already now say something about it. So suppose it's some kind of alloys. Yeah, a lot of CRMs are for industry, like metallurgy, cement, etc. If it's some kind of alloys, then this would of course be unacceptable if it's about main components of the alloys. Main components of alloys most likely have uncertainties around 1% relative or below that if it's some alloy CRM. Yeah. So it can be very low in such cases. But then if it is a nasty matrix with maybe even unstable analytes and really painful kind of analysis, then I would expect that something like 20 or 30% relative for expanded uncertainty would be quite okay, actually. Did I manage to give you some grading?
You just compared CRMs of metal alloys and reactive stuff that can decompose. I was asking about CRMs with the same analyte and the same matrix. So...
Very good. You are asking again a very good question. Sadly, I will have a very bad answer for your question. When previously you mentioned that money or cost might be the most, like the biggest issue with certified reference materials, then I said that it's probably not, but I did not say what probably is. I plan to keep that for a later moment, but now it's so good moment to bring this in. The main issue is with finding certified reference materials that whenever you start looking for a specific analyte at a specific concentration in a specific matrix, you typically find either one or even more likely zero available reference materials. So that a situation where you find a range of reference materials with the same analyte at similar concentration with the different uncertainties, I'm not saying it never happens, but it's probably so rare that I'm not sure whether we find that at all. perhaps in drinking water you can find something, but drinking water is not such a difficult matrix, so it won't be represented. The main issue is, as soon as you deviate a little bit from the most common analyte matrix combination, like lead in soil, yeah, some, let's say protein in milk powder and so on and so forth. As soon as you deviate from those very common situations, most of the time you sadly find zero available CRMs. If you really want to match both matrix and analyte. I'm sorry for my discouraging discouraging answer, but at the end of this CRM part, I will give you the, or actually, not so difficult. I can do that immediately. I will show you possibly the best database if you want to find CRMs. It's called Comar. So you can look around that database, yeah, and see whether you find what Gleb suggested, yeah, that a range of certified reference materials with the same analyte for the same matrix, but with different uncertainty. Yeah. That actually could make a nice ad hoc homework for you for the next Tuesday, yeah, so that whoever has time and possibility, please try. It's not difficult to use. I don't think I need to explain how to use. You are probably better than me in using web systems. Try to find such a thing, and then we can come back to this discussion next. So, any other questions before we move on? Apparently not. So now, one of the biggest hurdles is matrix matching. I've been bringing oftentimes here fruits and vegetables as an example. Yeah? So how many different fruits and vegetables there are, and if your CRM is in, let's say, potato, and now you have to analyze cabbage, then it's not the same thing, even though the analyte is the same. And if you are let's say, a food control laboratory, and every day new fruit or vegetable is brought to you, okay, today it's banana, then it's tomato, then it's, let's say, potato, then it's pickle, then it's whatever, then you will have a really hard time in validating for all those matrices. You will have a really hard time to have CRMs for all those matrices, etc. Therefore, there is some possibility of making some compromises in terms of matrix match. And here I'm bringing you foodstuffs. So these are all kinds of foodstuffs. They continue still on the next slide. So there are altogether 10 commodity groups. These are called commodity groups. Yeah. So high water content, high acid and high water, high sugar and low water, high oil, very low water, etc., etc. And here you see typical foods or typical, let's say, commodity categories. And here you see typical representatives of foodstuff. So essentially everything that we eat is in this table. Yeah, if you look, more or less everything. And now they have categorized those foodstuffs in such a way that, first of all, the big properties are covered by these commodity groups. So, for example, high water content, if you look what is here, then most fruits and vegetables actually are sitting here. And some fruits and vegetables are then sitting here, which are especially acidic, yeah, such as citrus fruits, like oranges and so on. Yeah. And then honey and nuts, okay, these are a separate thing. But here, for example, are sitting all kinds of cereals, grains, flour, etc., etc. These are all sitting here. Then almost everything meat is in category 7, milk products category 8, and so on. And now, you can do some matrix substitution within categories or within commodity categories, usually. Now let's put it also here, usually. Not always, but usually. So for example, if it's like beef, so let's say we have red muscle. This commodity category involves beef, pork, lamb, etc. So if needed, you can substitute beef CRM with a pork CRM. So suppose you are analyzing beef, but the CRM that you have is pork. Then you probably can make that substitution. Also, you can substitute usually, not always, different fish with each other. Then, of course, quite logical, which is possibly the safest, is that you can substitute tangerines, oranges, and mandarins all sort of interchangeable because they are really, really very similar. Okay. Now, within commodity group, substitution may be tricky, and you probably, like, let's say, should not do that substitution if you can avoid it. So that, for example, if you analyze meat, you should not really use fish certified reference material if possible. And then between commodity groups, such as, for example, you are analyzing cheese and now you take fish CRM. This is not a good idea. Very good. So this gives you some idea to what extent the compromises might be possible. But let me say one more thing. It will come later on in the slides, but let me already now tell you that if you have only two options, CRM with bad matrix match or no CRM at all, then it's more useful to analyze the CRM with bad matrix match than to just not do anything at all. And I'll come to that. I'll explain why that is. It's very important, actually. Okay. Are there, and this I did not mention, this is a European Union thing. So this comes from a European Union document, and this Europeans have developed it, but of course you can use it everywhere in the world. I mean, the pork is pork everywhere, and beef is beef. Any questions about these two slides? Okay, then I have a question. Please raise your hand who thinks that understood. People on the internet. All right, good. Yeah. Now here is another, maybe not how would I put it now? Not as rigorous, not as rigorous categorization. Here, all foods are listed into such triangle, which also is actually pretty useful concept. The ends or the corners of the triangle correspond to extremely, to foods extremely rich in either fat, protein, or carbohydrate. So, for example, this top here is 100% fat, and obviously plant oils and nuts and things will be somewhere close here. This corner here is 100% protein. So, for example, fish and maybe some protein drinks and things will be somewhere around here. And this corner here is 100% carbohydrate. So that they categorize these three main components like this. But then let me ask you, what was the fourth main component which we discussed in food? In any food, there's like 4 main things: carbohydrate, fat, protein, and one more. Water, yes. Yes, as a very, very big picture, the food could be considered to be composed of these 4 things. So this water is not like characterized here. So for example, you see berries are close to 100% carbohydrate, but berries mostly are composed of water. So all these fruits have more than 90% water in it, except some very few. Avocado, I think, is an exception, and maybe banana, and maybe a few more. But all those berries and oranges, they have more than 90% water. So this water is not taken into account. And you see now that again, the different commodities are marked here by crosses. And here the logic is that you can make substitutions when crosses are sufficiently close. Yeah? So when they are sufficiently close, then you can make substitutions. I would say the previous one is more rigorous. So for example, here you can see that honey and berries are very close, but honey is actually a very different matter, yeah, from berries. So I would not make a substitution. But this also gives some general idea. Now, what are the typical mistakes that people might make when selecting certified reference material? First, of course, is matrix mismatch, yeah, that you use matrix with a different, or you use CRM with a different matrix. As I promised, I will explain you, yeah, in one of the next slides, that in fact, using matrix mismatched CRM in many cases is still much better than not using anything at all. Then, of course, there's concentration mismatch that you can. Then different sample preparation methods. So, for example, if your CRM is about aqua regia extractable element content, but you determine total element content, and that's, of course, a mistake. And then there's an interesting thing, use of indicative values instead of certified values. I think we haven't spoken about indicative values. Indicative values are values or are concentrations of some components in the certified reference material that are not certified, but are presented for the analyst to be able to plan the analysis, plan sample preparation, and watch out for possible interferences. So let me give you an example here. Let's suppose it's some trace element certified reference material. Yeah? And trace element, you might want to use ICP-MS for trace element determination. But those of you who took atomic spectroscopy, you probably remember well. Those of you who took atomic spectroscopy, you probably remember well that there were a number of different interferences. In particular, ICP-MS was not very fond of having a lot of chloride. So that, for example, if it is a trace element CRM, it's very useful to put in indicative values of these main elements, which are not trace elements at all. But the analyst can say, okay, lot of chloride in there. All right. I have to watch out for interference. Maybe I have to dilute, or maybe I have to do something to maybe some collision reaction cell thing or something to avoid interference from chloride. So indicative values are helper values for the analyst to carry out the analysis. Now, which of these mistakes are really mistakes and which are more compromises? Let's again let's now paint those red, which really you must not do. And those that are compromises will then paint green. Could you, yeah, take it.
It's the use of
It turns out that I've done lousy job in explaining. You absolutely should use them, but you should not use them instead of certified values. You cannot use them as certified values. So suppose, besides those trace elements, you also determine sodium in your sample. Then, for comparing your sodium value with the indicative sodium values, you should not do. But the indicative sodium value you should use for tuning your ICP-MS machine for trace elements. Did I manage to explain? Yeah. So you use those indicative values for tuning your analysis, maybe modifying your sample preparation, making decisions how to program the mass spectrometer, what, I don't know, collision reaction cell type of work to use, etc. All that you should use. But you cannot compare your values to them as if they were certified. Okay, but now, again, which here are, oh, sorry, let's see. Christian has put in a comment. Let's see what he has. Yeah. Not a question, but some regional metrology organizations have catalog of unique matrix CRM based on the need of the economy, such as ASEAN reference metric. Christian, I haven't specifically checked, but this COMAR database contains CRMs from many countries, at least certainly from South America, for example, certainly from China. I guess the ASEAN reference materials might also be there. I would actually be very thankful to you if you would look into this ARMN 2018 page, yeah, and then if you could also look into COMAR and detect whether COMAR really contains also those same reference materials. Excellent, and thank you very much. Yeah, the next time we can discuss it. But now Luis has already given one answer. Sample preparation is a mistake, and yes, Luis, you have hit the nail. Oh, what I wanted. Move this. So, if you have reference value of total content and you are doing Aqua Regia extractable value, those you absolutely cannot compare. So that one is a big mistake. What else? What else could be a big mistake? What could be rather a compromise? Yeah, Gleb?
Generally speaking, we can give the same answer we previously gave to such questions. Depends on the method and everything that is acceptable and gives values that make sense using this method. Then that's all right. That's a great compromise. Otherwise, it's not acceptable, like with the preparation method example.
Yeah, but you see, there are still like clearly different situations. So different sample preparation, absolutely not okay. But in some cases, you can make compromises. Let's see if anybody comes up with any other idea. Yeah, Komal?
Like for concentration mismatch, as you already mentioned, if it's like more than 10 times, that you cannot use that. But if it's usually like 3 or 4 times, you can like compromise on this factor.
So yeah, you can make some compromises.
With matrix mismatch, I think while comparing like two things, if you have CRMs or if you have like a CRM with like a little bit of matrix mismatch, you can also make like some compromises on this one. But I think it's not like that serious as like different sample preparation methods.
yeah, you can also, matrix mismatch also you can make compromise. And perhaps let me then answer myself the last one, indicative values instead of the certified values you should not. So this is really, really a mistake. And now, I promised to explain that in some cases, even really very mismatching matrix still might be useful. So using a CRM with suboptimal matrix matching still can be useful for detecting problems. So for example, if you analyze, if your matrix is pork, CRM is fish, you analyze the fish CRM, then if you get close to the reference value, you should not make any big conclusions. You cannot go to the customer and say, oh, very good, see how good match I have, because it's different matrix. But if your value is, let's say, 5 times off from what is in the CRM, meaning grossly off, then you can be almost sure that you have something wrong with your method. So that, again, this is a sad news. Analysis of matrix mismatching CRM in some cases is beneficial, but you cannot get good news from there. Because if the news is good, you cannot really present or use. But you can get bad news, meaning you can get the information, oh boy, I have to go back to the lab and rethink how I'm doing the analysis if it's completely off. This is why I'm saying, if there's no good matrix matching CRM, even mismatching CRM still is better than not doing anything at all. Did you get this point? No? Okay. So now we come to different practical considerations, and I will explain most of those things, and then we turn to the example CRM certificate, and we will look at some of the things, how they are written there, and how they should be interpreted. So there are a number of things that typically are specified with a certified reference material, yeah? And I'll come to those. I'll come to those in the next slide. So typically, it is specified how to store, how long is the shelf life, how should you open or close the bottle. Seems to be trivial, but it's not trivial. It might be very tricky. What is the minimum withdrawable amount? And anything about drying, moisturizing, etc. So there can also be something like that. But I think even before we go, I can already now ask you this question. This actually resonates well with what we discussed yesterday. Yeah? Oftentimes in CRM bottle, it is said something like, okay, yeah, there's 50 grams of the certified reference material. Here, the minimum withdrawable amount is 1 gram. What does that mean? Why is it specified? Why am I not allowed to withdraw 300 milligrams, for example? What is behind that?
I'm not sure, but I think it is specified to like get the representative thingy.
Exactly. This is purely in the interest of representativeness, in the interest of sample representativeness. And this does not come into play if it's like drinking water, yeah, which is homogeneous, yeah, or plant oil, which is also homogeneous, but with soil, some cereal, food product, etc., it might be really important. And perhaps I'll try to even illustrate that. So suppose we have a CRM maybe some soil, and it has both like organic matter and inorganic matter. So some particles in that soil are humic acid, like organic particles. Some particles are like sand grains and inorganic particles. Yeah. So this is one type of the particle. Yeah. And I'm now trying to make the other type of particle more or less as abundant. Yeah? Okay, yeah. In very broad terms, it seems to be like 50-50 now. Yeah? If you take all this as your sample, it will be 50-50. It will be representative. Now let's try to find some. Yeah, I already found. Suppose now that instead we will take orange. Yeah? Instead, we will take only this part here. If you now look, there are only, this counts for 2 because there are 2 dots, yeah? But there are only 5 red dots. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 14 blue dots. So if you take too little, you might get completely skewed distribution. It's very important. It is very often specified with solid CRMs. So I hope it was understood. Yeah, Hans, Elvin also. Yeah, Elvin and Hans, many thanks. You hit the nail. You answered exactly correctly. I did not notice your answers in time. All right. So let's see now. Storage. Yeah, come on.
Sorry, but like on slide number 33, as you said, like there can be compromises when we are like using mismatch matrix CRMs. But do you need to specify if you're using that matrix? Because if you're a food control lab and if you're analyzing fish and you're using the CRMs that is used for pork, so you're not going to get the conclusions, but you have to present your results anyway. So will you be informing the customer about it? Or will you be considering this as an uncertainty source and then quantifying the sources while presenting the result?
Very good points. No, you cannot really present this to the customer because it's not okay. And you cannot really use it like, you should not use it like routinely. You should use it when you are still developing the method. Suppose you have managed to develop a method. Okay, good, everything works. Now I should check it with something. But no good CRM. Well, okay, let me take this one. Yeah, matrix is not matching, but let's see if I get at least close. And then you find, I'm 10 times off or 5 times off. Then you know, even if you still haven't found a better CRM, or maybe there will be an interlab comparison only a few months away, which will have a matrix match. But now you already know, my method certainly is not okay. I have to go back to the lab and try to improve, try to find out what I'm doing wrong. So it is useful mostly during method development stage and initial validation stage. Yeah, sadly, it is useful for inviting bad news to you. But it's better to have bad news during method development than being in court with the customer, being challenged by the customer in court and facing a fine or penalty of, I don't know how many hundreds of thousands of euros, etc.
So for the food laboratory, if it's like well established and been working for like a lot of time, so it will have like CRMs that's completely matrix matched?
You see, not necessarily, not always. As I said, you simply cannot find on sale any CRM with any analyte matrix combination that you may wish to have. Simply not on sale. So that those labs who are well established, they of course find all of the CRMs that they wish, that they possibly can. But on top of that, they use in interlaboratory comparison. So interlaboratory comparison, which will be the next big topic after CRMs, is another very good way of checking how good you are. And I'm glad to say that interlaboratory comparisons oftentimes tend to be, put it, more available. Yeah, you might find more easily analyte matrix matching or analyte matrix combinations in interlab comparisons than you find in CRMs. You are tempting me now to ask a question from you. Let's see. What do you think could possibly be the reason why you might find more analyte matrix combinations in interlab comparisons than in certified reference material?
I think because different laboratories are doing like different kind of work. So it's not like the exact method or everything. You can be using like different method or something, but still you get like the values or this uncertainty range that is associated with your analyte. So maybe that's the reason.
I did not understand your answer.
You rephrase it like maybe they're using different methods or different concentration levels of the analyte. So maybe that's the reason that you can get the like more match than CRMs.
I don't think so.
I think maybe the reason in certified reference material, it's like commercial, so people have to make like big batch, like 50 kilograms or like more. So it's not reasonable for like them to make like certified reference any analyte or out of cut. So I think in labs or like 1 kilogram of meat.
Sort of. Let's see. You are not obliged to know this. I'm actually jumping ahead. I simply wanted to ask to see your thinking about this. So do not be afraid if I'm saying that is probably not the reason. I also don't know for sure, but I think I probably know. But let's see what. One moment, Gleb. I will read what Louis is saying. The ILC samples need to try to make it as real as possible, so they will emulate the matrix for all the lab tunnels. Yeah, yes, Louis, but the CRM producers do exactly the same. Yeah. Gleb, what was your answer?
I wanted to propose that there are more labs than there are CRM makers, and by orders of magnitude more. And definitely CRM makers make like CRMs in big batches, so they just make one for an amount of time, whereas lab for the same amount of time manages to produce tens analytes with different.
Yeah, but this is more than correct that there are many more labs than there are CRM producers. But in this case, you should not compare number of labs to number of CRM producers, but number of ILC organizers with number of CRM producers. And here also, you are probably correct. And this is actually a good point. I didn't think of it. There are probably more interlaboratory comparison organizers than CRM producers. And this like ties in what I was going to say myself, but let's see what Christian says. Christian says, but ILC samples turn out to be CRM samples later on, so they should somehow be the same. Christian, this is a very good point, but let me just say it's not always like that. I will explain that in more detail when we go to the interlaboratory comparisons. So sometimes it really is exactly as you say, but I would say most of the time it's not. But okay, let me now try to answer this question myself. if you want to produce a CRM, first of all, it has to be stable for a long time. You have to have certified value or certified values, and you have to have uncertainty. So it's a lot of work. For a typical interlaboratory comparison, this simplest interlaboratory comparison, which we call proficiency test, I think I already briefly mentioned that some time ago. The organizer does not need to ensure that the sample will be stable for 10 years. It's sufficient if it's, let's say, a couple of months. Secondly, the organizer typically does not determine the reference value at all. The reference value is typically obtained as a consensus value from labs. So it's massively more easy to organize a proficiency testing run than to certify a batch of certified reference materials. Simply so much easier, because long-term stability, not really a big issue. You also have much more freedom. For example, if it's just few months, you could, in principle, also do like fresh fruit, okay? You make some fruit slurry, you send it to the participants and some, let's say, refrigerated conditions, and they can analyze that fruit slurry. You don't need to do any freeze drying, nothing of that kind. So it's simply simpler, and also you have much more freedom with your matrix and how it is organized. This is possibly the main reason. And now, Komal, I'm coming, or was it my time? One of you asked that it's an established lab. Yeah, does the lab have all the CRMs? Probably not. But the lab typically looks out for all possible interlaboratory comparisons where only they could participate and takes part in all of them. All right, let me see. Christian has new message here. I see. If maybe we are talking about PT. Yes, we are talking mostly about PT, proficiency testing. And why mostly about PT? The reason is very simple. Most routine labs don't really participate in other interlaboratory comparisons than only those simple proficiency tests. PT I eventually offered in the future, many rounds as required by the once more. Yeah, exactly. Yeah. PTs tend to be proficiency, tend to be organized in such a way that, for example, if I'm a big PT organizer, then I might have a drinking water PT, which I maybe organize every year. And I know some big organizers organize every 3 months. So there will be 4 rounds a year for very widespread matrices such as drinking water. Drinking water, of course, is a good example in the sense that there's a lot of CRMs for drinking water, lots of proficiency testing, etc. Because drinking water is a very simple thing, yeah, differently from soil or fruit or vegetable or meat. All right, so any questions before we move on? Okay, if not, then let's come back to storage now. So Earth's atmosphere has all these nasty properties. It's oxidizing, humid, acidic, yeah, and contains microorganisms. And all of those can attack our samples and our analytes. So that especially in the case of delicate analytes, the opening and everything and storing and everything is closely prescribed for the certified reference materials. Now, first is temperature. Usually there are 4 different grades, which either you can store at room temperature, in refrigerator, in freezer. Freezer is essentially the same kind of freezer that you have at home, yeah, and refrigerator is also the same kind that you have at home. And then deep freezer. Yeah. I would say most of the time, the producers of CRM try to fit within these 2. First of all, it's more convenient for the labs but it's also more convenient for themselves. Because to store something for years in deep freezer is pretty costly. Yeah? You have to have those huge deep freezing rooms. Yeah, not to. Sorry, in freezer is costly. In deep freezer, it's even more costly, obviously. Yeah? Then darkness can be important. And my advice to you is very simple. And not only for CRMs, but for any chemicals, store all chemicals always in darkness, period. Because darkness is very cheap. It's very easy to find a cupboard which you put chemical in and close, differently from deep freezer, yeah, which is not really cheap. So don't store any chemicals so that they can get light constantly. It's very easy to do, actually. And then, of course, controlled humidity might be sometimes important. Typically, they are closed, even if they are hygroscopic. They are closed so well that you still don't need to store them in a glove box, in an inert gas glove box. This would be very difficult for most analytical labs because most analytical labs do not have inert gas glove box. So that usually you are still allowed to store it like under normal air humidity conditions. Now, shelf life, most of the time is given in the certificate, yeah? And it is dependent, of course, on storage conditions. And whatever the manufacturer quotes as the suitable shelf life only is valid if you store properly. So if you need to store at -20 and you store at +4, then you simply don't know what your shelf life is. And the manufacturer of the CRM does not then take any responsibility if it cuts spoil. And very important, shelf life most of the time is given for unopened bottle. As soon as you have opened it once, the manufacturer doesn't want to take any responsibility anymore. So the big recommendation is that when you open, use it up as fast as you can. There are also such CRMs which are called one-shot CRM. One-shot CRM means that when you open the bottle, you should use all of it. Yeah, you should immediately use everything. That's in a way very convenient. You don't need to worry at all. What about shelf life if it's an open bottle, because you will not have anything left. Yeah, you will have used up all of it. And rules of thumb are here. If it's elements, it's oftentimes very long shelf life. It can be years, tens of years. Yeah. So, for example, dried soil powder and some elements in it, really not much can happen. Also, if it's some minerals, alloys, cement, etc. But then, if it's some bio, organic, etc., then completely different and can be short. Next thing, opening the bottle. So, first of all, you should carefully read the instructions. Yeah. You should open the bottle for as short time as possible. This, of course, applies for any other chemicals also. Whenever you open the bottle, you should already have beside you all the instruments and things with which you either withdraw or you pour out into some vessel, etc. You do that immediately. Sometimes you can encounter different additional requirements. Like, for example, shake well before opening, yeah, or open under controlled humidity conditions. That last one is again tricky for the simple labs to meet because controlled humidity ideally would meet inert gas glove box, but you also can then do it under the flow of argon or nitrogen. And argon and nitrogen lines are oftentimes available also in simple analytical labs. Now taking the sample, you certainly should respect the minimum sample amount, minimum withdrawable sample amount. And as I already mentioned, sometimes there are the one-shot CRMs where you have to take all that is inside so that the minimum amount is the whole bottle, the whole amount of the material in the bottle. And now one more thing extremely important is contamination. Contamination comes in play, especially in the case of such materials where we have traces, of analytes, and especially if those traces are widespread compounds or widespread elements. So for example, if it's something like traces of iron in some, let's say, ceramic material, then it's a big issue, or traces of silicon or traces of calcium. Because all dust particles flying around contain iron, silicon, calcium, etc., all those elements. Yeah? So again, you open for as short time as you possibly can. You might want to work in a laminar flow hood. I think I explained, what laminar flow hood is, so it blows air against you so that all dust and thing like flies back behind your back, and in the hood there is almost no dust. So laminar flow hood can be very useful thing for trace analysis. And of course, the next step or the next level is clean room, which is a room where you can enter only in special clothing. All the air into the room comes from special filters, etc., etc. Those clean rooms are again not available in most analytical labs, so they cannot be. Usually, they cannot be made as a general requirement. Then, use appropriate tools. For example, don't go with metal spoon into the trace element CRM bottle. It's actually better to pour some material out, not go with something in, because that what you put in might not be maybe clean, but of course you have to make it clean if you take with something, etc. And never return any unused part of CRM into the container. This of course applies for chemicals as well, but for CRMs it's especially. Pour out a little bit too much, but you don't put that. And of course, you close immediately when you finish taking. And minimum withdrawable amount we already discussed. So, any questions?
I was wondering if you know anything about metal alloy CRMs. For example, can you do they have shelf life at all if you use them, for example, in an XRF analysis? And are you for example, allowed to grind them down if they get contaminated?
You usually cannot really grind metal alloys. They're too hard for that.
I mean, if the surface gets contaminated.
You mean it's some metal blocks? Yeah. I would say I expect, I don't have much personal experience with that, but I know that people have such metal blocks as CRMs. Maybe they really need to be cleaned on surface from time to time. I think probably what people do is the following. They simply take it out of the box only for measuring, put immediately back into the box. And as with almost all metal surfaces, some oxide layer, of course, will form. But if you don't keep it in a humid condition, then that surface can stay intact for many years. Of course, depends on the alloy. Like if you take a simple table knife, its surface is the same for years and years and years and years. And if that alloy CRM is the same, then like similar thing. I guess in those cases, if it's metal alloy in the form of a block, It's probably also written by the manufacturer, okay, how you should use it, how you should keep it, should you do anything with the surface. So the certificate is always your like stop number one, yeah. Now I see Christian is writing. I'm not sure if this is also a consideration, but when we are dealing with powder sample, they tend to be electrostatic. Yes, they tend, and when taking out samples, tend to scatter or stick on the wall of the bag. This is a very nasty thing, and I actually explained countermeasures for you during the uncertainty part, if you remember. When we had the uncertainty of weighing, I explained it's very good to earth the balance, to have a metal plate besides the balance, also earthed. Yeah? And if all that is done, and all you put all your vessels and things onto that metal plate, if all that is done, usually not that bad. So earthing is like the cheapest and easiest way to counter the electrostatic things. But Christian's point is very valid. If it is a very dry powder, as it oftentimes is with certified reference materials, then yes, this electrostatic thing can be very annoying. Now, sometimes it is necessary to include some correction for humidity. This is now an interesting thing. Let's see. This is an excerpt from one certificate, again, extractable trace elements in organic rich soil. So the sample must be used as it is in the bottle. Yeah? So the sample must be used as it is in the bottle. But the reference values apply for the dry mass, not for the slightly humid sample that is in the bottle. So in this case, obviously, the sample might not be completely dry in the bottle. Now, you should still use the sample as it is, and thereafter you should make a dry mass correction with a separate portion of 1 gram, which you dry in an oven at 105 degrees centigrade for 2 to 3 hours until constant mass is attained. What you do, you first use the CRM the way it is, yeah, for your ICP-MS or whatever measurement, and then in a separate sample, you determine how much water was there, and then you recalculate your original result to the dry mass, like leaving the water out. Can anybody guess why does it need to be so complicated? Why can't we do so that we take a sample, we first dry, and then we run ICP-MS analysis from the dried sample? Why do we need to do it 2 times? In addition, the other aliquot might not have exactly the same moisture, so you might even get some additional uncertainty. Why is it specified like that? I have given some hints in the uncertainty sources part of this course in the very beginning. Komal?
It can be because when you heat CRMs, maybe some stuff or some components in the CRM can decompose.
But it's elements. Elements cannot decompose.
Okay.
But you're on the right track, actually. But you're on the right track, but you should think a little bit different. Yeah,
Or maybe change the composition?
But what exactly?
Microbial or...
No, that's not an issue. Yeah. You see, microbes cannot do anything if you do this everything maybe in 1 day or in 2 days. Yeah? So microbes are not in play.
I'm not sure, but there are some reactions that can be catalyzed by the presence of elements. So maybe that's the reason, if there are like some other stuff present and they can be catalyzed.
Yeah, but how is that the problem if some other reaction is scattered? Elements are elements. Yeah? Even if the elements react in some way, it's not really a big problem. Yeah? It's elements, it's not compounds. So let's see if anybody can guess. Hans is saying, you said before that the contribution of moisture is more significant in weighing smaller amounts, like in standards, but not with samples where we usually weigh much higher. Yeah, Hans, you see, it's not the case here, no. Oh, interesting. Okay, Gleb.
CRM producers want us to use up their CRM as fast as possible so we can buy a new one.
No, they won't, but this is not the reason. Maitane, you wanted to say something. Okay, let me put in one phrase. Let's see if it rings bell. I will simply say analyte losses. Oh, anybody? Ah, some people from the, yeah. Could you throw the cubic? Yeah.
I think the done to make represent sample because you try it.
Yeah, but if that would be the, you see, we could do it exactly this way, that first we determine humidity by doing exactly what they suggest. Okay, some water evaporates. Now I have this dried sample and I bring this now to my ICP-MS lab and do the analysis. So this would do perfectly the same thing that you.
Yeah, but you can't make sure that the oven is 100. Something else that had been in there before.
Yes. Indeed. One is cross-contamination. The other, yeah, beautiful. And the other one is that some elements in some oxidation states actually might partially already volatilize at 105 degrees. Like some certain ways of selenium, boron, etc., depending on in which state they are. So that, yes, this heating might either contaminate or lead to removal of some part of some element, so you might get wrong. Gleb, yeah.
So what exactly is the mechanism the elements evaporate from the sample by?
Why it happens? Suppose if the selenium is in some organic compound, that compound simply might partially evaporate at 105 degrees. Okay, yes, probably zirconium will not evaporate, etc.
So all those elements have to be in organic compounds in order to evaporate?
Usually, yes, but as you notice, this is organic rich soil. Yes, they can be in organic compounds. You want to say something more?
So why can't they dry this CRM themselves and present it in a dry way? Why we have to make those drying ourselves in the first place?
I cannot answer this. So for some reason, they have decided to ship it this way. Okay, but now what I leave as a homework for you is this. How do we do this calculation? In the past, I never really explained this because it seemed too simple for me. But on one year, I asked students, and then it turned out it was a major headache for students. How do we do this humidity calculation? So please think at home. If I take some mass M and now I dry, I get another mass, how much water evaporated. How do I now correct my results, my ICP-M results with humidity? What formula do I use? Next lecture, we will look what you came up with, and then we will see how well you. Now, dissolution extraction. Another important part. So seems trivial that, okay, if you dissolve or extract something, yeah, you follow the procedures and so on and so forth. But also here, mistakes are actually quite frequent. So whenever you do element analysis, the dissolution really has to be complete. And this can be quite difficult with some elements. For example, if you have any of these in high levels, what you can get is a solution which is sort of solution, but it's hazy. Some haze is flying in there. And it can easily happen that most of your titanium or zirconium actually is not in dissolved form, but is in that haze. Now, you may need, and here again, I can only refer back to the atomic spectroscopy. I'm not going to explain that in detail here, but whoever took the atomic spectroscopy class, you remember that Vasily Rosen explained quite a bit what vessels you can use, what acids, etc., etc. So this is all important part of that. So you really should do all things in correct way. And most of the time, if it is ultra trace element analysis, then generally you should not really use glass at all. So your samples should, or your solution should not be in contact with glass. Because many elements can leach out of glass, including some of those which might be your. And of course, for organics, it's even more tricky. Your extraction efficiency has to be under control. But here again, we do not go into details at this stage. We later on will see how to determine recovery, which is a characteristic which determines extraction efficiency. And then I will give some more things about that, but not at this moment. And now, if you have questions, let me stop for a moment before we go to a CRM certificate and start looking at what is written there. Yeah, Caleb, please.
What materials should you use for your vessels if that's not the glass? You can't use glass.
Most of the time, it's different plastics. But in some other cases, it also can be quartz. So quartz is also very good because it does not leach like sodium and potassium, etc., into the liquid. Plastic is like more common. And quartz you obviously cannot use if you use HF. Yeah.
So glass was not recommended when silica was a problem. Can you use quartz when you do silica traces?
No, absolutely not. When silica is a problem, then neither glass nor quartz. Quartz leaches silica.
And with plastics, I guess you should use Teflon. Is that the most common?
Teflon, but there are different other fluoroplastics which are pretty good. So it does not need to be exactly Teflon.
Thank you.
Okay. So here in this slide now, there are things that a certificate of a good CRM should contain. And we will now take this, our example CRM, and I will open it from this PC. I have it. And we will see whether it really is the way it should be. All right, here we are. So this is a toasted bread certified reference material. The analyte here is acrylamide, as you can see. Well known for those of you who take the seminar. You've seen it like inside out. And then, first of all, of course, you have to have the analyte mentioned, you have to have the matrix mentioned, you have the certified value, you have to have the units, obviously, you have to have the uncertainty. Then it also is explained here where this certified value comes from. This is explained here. Unweighted mean of 11 accepted sets of data obtained in different laboratories and or with different methods of determination. So this is again what I stressed last time. I stressed that we should have, as far as possible, different methods. We will not have time today, but next time I will also show you the certification report of this same CRM, which is much more voluminous and more detailed, and we will see what are those methods. By the way, they might even be listed here. Let's see when we get down. And then we've been here discussing several times what is the proper and good way of presenting measurement uncertainty. And actually, we already last time managed to find out that here, this is perfectly okay the way it is done. Yeah, it enables nicely anybody to use this uncertainty either in their own uncertainty calculations or comparing results, etc. Okay. Next, the certificate is valid for 1 year after purchase. Here is your shelf life. Yeah? So this one you cannot store for 10 years. They might be storing it for longer, but when you bought it, you have to use up during 1 year. Otherwise, the manufacturer or the producer of the CRM does not take anything. You don't see here any sales date simply because it's a sample downloaded from the internet. Yeah, if you buy it, actually, you will get here the sales date also. Now, the next thing, which I've also been discussing here, minimum withdrawable amount, 1 gram. Clearly stated. And this was produced at the same IRMM, which I already mentioned yesterday, Institute for Reference Materials and Measurements. And part of the European Reference Material Consortium. And this certificate is from 2006. And here is the boss of this institution who then signed this certificate. Now let's move forward. Yeah, here it also says that this facility is accredited by BELAC. BELAC is Belgian Laboratory Accreditation Agency. Yeah. So BELAC has accredited them for producing certified reference materials according to the ISO Guide 34. So this is one of those guides that I also. Oh, yeah, not bad, yeah. Now the next thing, description of the sample. It consists of 30 grams of toasted bread powder of particle size smaller than 500 micrometers. This is 0.5 millimeters. If you remember, I said 0.3 is something like considered sort of an optimum. So this probably agrees with that. Stored in amber glass bottles under inert atmosphere and kept at temperature minus 20 degrees until delivery. So at IRMM, they are storing it at minus 20 degrees centigrade. We will see whether there's any information how it has to be stored also in this certificate. Okay. Storage is here. Upon receipt, an open bottle of the material should be kept at a temperature equal to or lower than minus 20 degrees for long-term storage. However, the European Commission can build response change, etc. So what it means is they send it to you probably without refrigeration. So few days at plus like 20 degrees, probably it will survive. But when you receive, you should put at minus 20. Then at minus 20, you store as long as you need. So if you need to store it for a few months. Okay. Now, what I notice is that's 11:45. There are still things here that we should cover. Yeah, so we cannot manage it in 1 or 2 minutes. So we continue from here next week. And what you can already do at home, it's very useful if at home you already investigate on your own this certificate and try to find out whether anything that is listed here is missing, whether there's any important information. And then, of course, yeah, please do that calculation. And then whoever has the time and wish, please try to find the same analyte matrix combination CRMs from Comar, and then find how they differ by price and by the uncertainty of the reference. Now, I say Luis is right, or has written one thing. Is CRM's contamination taken into account as a component of the CRM's uncertainty? It might be implicitly. I don't think it's ever taken into account explicitly, but implicitly it might be taken into account by the mismatch between laboratory results. So I don't think they explicitly consider it. So if no more questions, then thank you, and we close.